We are going to talk about how to monitor fuses and circuit breakers for energy monitoring and other conditions that you may want to do. NXP has the perfect solution for doing this type of monitoring using low power RF solutions. The first condition you want to do is monitor inside of a panel, so maybe metal, it may be other material. We have a solution that can get around metal objects and inside of a metal panel. The idea is that it is using a self-healing tree architecture for wireless, and therefore you can place routers near the panel. It'll be strong enough to pick up the signal and then relay the information to additional routers or to a gateway computer. The routers are shown as square pink boxes and endpoints are green boxes. What kind of things do you want to monitor inside the panel? A voltage and temperature would tell you if a condition is being exceeded, breaking down, or a safety hazard. Energy consumption is really important, especially now with energy being mandated and smart metering going into houses and industrial installations. By doing it inside the panel gives you better results than trying to measure it directly at the appliance, and it should be lower cost as well. Error conditions can be reported to alert the proper personnel. You can remotely monitor these things with internet connections or maybe a text message on a cell phone. And the main goal is to make it easy to expand the network. There's lots of solutions that allow you to install for a particular installation, but as you start to add devices, it makes it more and more difficult. Some of the features of the device and what it can do, two different types are supported. New designs, you are not violating the UL requirements. You would identify it as you install the equipment inside the power panel. For aftermarket products, if the UL or the panel has already been UL approved, you may be limited on where you can pull the power off. Because NXP has the lowest power microcontrollers out there, you would be able to run it off of a coin cell and ping the data as required, and the data would then get out of the panel using a beacon signal, and therefore a coin cell battery would use it. You would not be pulling off the power rails. Two different ways of monitoring power. You can plug on an adapter right to your appliance. That's kind of bulky and unwieldy, and it gets costly the more devices you start to monitor. It gets especially costly if you are monitoring three-phase or 220-volt high-power devices, such as maybe an HVAC unit or a large motor controller. Better choice for those high-power devices would be to do it directly inside of the panel, and therefore you'd monitor it across a circuit breaker or a fuse, and you'd easily be allowed to do that without plugging on any devices out in the installation site. Panels are metal, and therefore you would assume that it'll be difficult to get a wireless signal out of them. That's not true. They are typically not sealed for EMI, therefore there are gaps around the door, around the hinges, the conduit pipe coming out of the unit. They are all gaps that allow a 2.4 gigahertz signal to get out. We have run testing on panels, and it'll get out of most panels, especially if you can put a router close by to the opening of the panel, and that router would now relay the information to a next router and then route the signal to a gateway, remote gateway. The NXP JN5148 device, microcontroller, can run off a battery. It's very low power. Plenty of I/O on it, so it can do an LED or LCD output that you require for monitoring. It also has a time of day timer in there that can be run off of a 32 kilohertz crystal. There's UARTs that can run a gateway. You can also use I2C if you want. Lots of peripherals can be put in, either analog or digital inputs to measure power and or temperature. One of the unique features of our device is that we can operate an LCD device. We can operate a 1x14 LCD segment, direct drive it off of I/O pins. That saves you the cost of an LCD driver and allows some pretty wide range of diagnostics that you can show with a 2-digit 7-segment LCD. Requires very little CPU time, so it can run a software stack and your user application without a problem. One of the benefits of our solution is very, very open and can support a wide variety of sensors, whether they're Hall effects, current sense resistors, current transformers. They all have their pros and cons for measuring power consumption. We can support any of those because we have analog and digital inputs to the device and plenty of them. If you wanted to measure all three phases for power consumption, it can be analog inputs. There's 4-channel A to D converter, 12-bit, that's very precise. That can be used for analog input on the sensors. Or if you had digital sensors, I2C, there's plenty of those, SPI bus and so forth, that you could do sensor inputs on the device and measure all three phases in one panel. Some applications you don't have all the phases available, and so what you want to do is aggregate the data. That would be easily done. Again, you can measure the different phases in each panel, send the data off to a router, and then the gateway or a PC would aggregate all of the data and measure it. You could insert as many or as few routers as required to get the signal over to a common point that could aggregate the data. Microcontroller is a 32-bit processor, plenty of onboard RAM to run your application, to run the software stack, lots of I/O pins available for your use. Here's one of the benefits of using a wireless stack such as GenNet or Zigbee Pro is you can start to add in other readers as necessary. If you find a dead spot in your facility or factory, you could easily add in another reader. This networking tree would self-heal, find an alternate path back to a gateway, and allow you to easily add more devices or, again, to get around dead spots. The software architecture works from a MAC layer and API calls. The user really doesn't have to know what hardware is underneath the application. The application is doing API calls. So as we add other architectures, the user all he has to do is rebuild his code or recompile it, and he can run it on the new architecture or a new software stack. If you're doing an aftermarket product, again, you may not be able to pull power off the rails inside the panel. For those applications, we have an RFID tagging application that uses a battery. It pings the data outside the panel, runs off of a battery for a very long time. As you can see, if you're pinging once a minute, it would last almost 10 years off of a coin cell battery and not require any power. And the more of these tags you do, it can still support a wide variety number of monitoring points. So even if you're pinging these tags once every 60 seconds, you could still get over 6,000 monitoring points that could be measured. The data transmission uses broadcast mode, and that shows you, again, for battery type of applications. For if you're able to pull power off of a panel, it's a much more straightforward joining a network. Or you can mix and match. You can have some measuring points that are running off a battery, other ones that are running off of AC power and joining the network. There's lots of ways to architect a design properly that you have redundant gateways or servers. You can mix and match fuse monitoring with circuit breaker monitoring, and again, running off of AC or running off of a battery. You can mix and match those in your application. We also have a TCPIP stack that runs directly in the micro. It is a reference design at this point, but it is a workable reference design. You can purchase boards, as we'll see shortly. It allows you to collect data running GenNet self-healing tree throughout your building or home, and then one node runs then a static IP address and allows you to collect the data. That one node runs the GenNet network stack. It can do a temperature or user application, runs the TCPIP stack, and it can host web pages with Perl programming language on them all in one chip. So it makes a very, very low-cost TCPIP gateway. You should be able to build this for under $20. All that's required is an Ethernet PHY, which can be capacitively or using transformers coupled into your Ethernet jack. Antennas built in. Here's a slightly different reference board that now gives you USB connectivity. Again, very low cost. You can still build it. Modules can plug on and off of this reference design. This one accommodates an external SMA antenna. It still uses the Ethernet PHY, and it has an FTDI USB chip programming port that you can program the devices off of. One of the benefits of using NXP technology is we have a wide variety of software stacks. You can use GenNet or a mix of GenNet and Zigbee. If you choose to use Zigbee, we do have a fully qualified Zigbee Smart Energy software stack. We'll be having the Smart Energy 2.0 shortly. Profiles are available and so forth, so you now now can interconnect with some of the home automation or smart energy that's already being done in the facility or in the home. Data collection devices, here is a LCD board that is in the development kit. It can be used to monitor the data. You can walk in on the network and use it to locate fuses or breakers. Maybe you have an IP address or a MAC ID that you're reading, and you can read off the condition of the devices. One of the benefits of using NXP is that we have a reference design showing you how to go to a broadband network. In this case, using a TCPIP gateway, you can go off to a Wi-Fi router or Ethernet connection. Now you have remote access to all of your sensors. You could put Wi-Fi into all your panels that you're monitoring, but it would be much more power, consume much more power. It would also be a much more costlier solution, and it would not do the self-healing tree that a 15.4 network could offer. Same design type, but now if you wanted to use a different backhaul network stack, say you wanted to use Modbus BACnet, those could easily be done by using a different interface device. You could now go from TCP/IP over to BACnet and have a very low cost backhaul network for industrial type of applications. Different displays can be offered for this monitoring condition. The LCD that we already showed, an in-premise display that you design. We also do have reference designs and customers that can offer a PDA or cell phone interface that has our 15.4 Zigbee Pro device running on an Apple iPhone interface. Feel free to get a hold of your NXP sales force to get more information on that. One of the benefits from NXP is the wide variety of software stacks. We will help you choose the right stack for your application. GenNet has been deployed for many, many years, and it is a very viable solution, royalty-free. But if you want something more industry standard, we have 6-LoWPAN, we have Zigbee Pro, RF4CE, or even a Tritium stack. Hardware monitoring allows you to use from NXP, allows you to 2.4 gigahertz radio, worldwide acceptance. We do have external readers and routers that are configurable that allows the data to make multiple hops to get to an internet gateway. And the internet gateway allows you to remotely monitor all of these conditions. NXP GenX has a complete solution of software stacks, modules. We have the technology based on 15.4. Any kind of software stack you want, we have available, and it's easily scalable. You can add as many devices as you want on your initial installation, or you can certainly add devices later on, which is important. Once you've installed a basic installation, you can easily upgrade and add more devices over the network. And for scalability, you can also update the software over the network. So from a remote TCP/IP connection, you would be able to reprogram all of the embedded code that is in each one of these monitors. That offers you a very exciting addition to add to your product line. Any questions, feel free to get a hold of your NXP sales force. Thank you very much for listening.